Alright, welcome to the second video of washer method. So what we're going to look at is two examples of taking an area and rotating it around an axis other than the x-axis or the y-axis. So some other vertical or horizontal axis. So in the first example, we have y equals x squared minus 2x and y equals x. So here we have the blue function and then the red function. And we're rotating it around y equals 4. So right here, this green one. Okay, so clearly this is something not the x or the y-axis. So y equals 4 is a horizontal line. So we're rotating around something like what we did with the x-axis. So we're going to be in terms of x. So rotate around the x-axis or any other horizontal in terms of x. Okay, so the first thing we want to do is find out what the boundaries are. So we know we have an intersection at x equals 0, and then we have an intersection at x equals 3. So we can go ahead and set up our integral. Okay, so from 0 to 3. And we always want that pi out there, so don't forget that. That's why I like to write that right at the beginning. So now we need to determine what the big R and the little r will be. So the key with this, if you're not on the rotating around the x or the y-axis, you need to go to the axis of rotation, and then we draw a line, or think about drawing a line in your head to the function itself. So the first function we hit, that's going to be the little r. Okay, so the second function, that's a much longer line, that's going to be the big R. Okay. Now the question is how do we determine what the little r is? Well, it's clearly going to the red function, the y equals x line. But if I just put x in for little r, that would actually give me the height from the function to the x-axis. That's not what we want. So think about it. This entire distance from x, the x-axis, all the way to y equals 4. That's a total of 4. So how do we find this little bit? We need to take away the function height, the function value. So we're going to start with the axis of rotation, which is 4, and subtract the function. Okay, so that's the little r. And then same thing with the big R. We start at axis of rotation, and we're going to take away the function value. So the function value is x squared minus 2x, but I'm going to carry that negative through to the whole function. So now we have our big R set and we have our little r set. So remember, big R squared minus little r squared. Okay, so if they want the setup of the function or the setup of the integral, this is all we need to write. If they want you to solve it, so it depends on if it's a calculator problem or a non-calculator problem. So clearly, obviously, the calculator problem, we just throw that in, we get an answer, and we're done. If it's a non-calculator problem, then we actually have to go through some algebra to clean this up before we can integrate. So I'm going to go ahead and walk you through that. If you don't think you need help on that, you can skip ahead. So integral. So now we have a trinomial times a trinomial. So we need to take each term and multiply by all three terms. So 4 times 4. 4 times negative x squared times 2x. Sorry, negative 4x squared. 4 times 2 is 8. Okay, and then the middle term multiplied by all three. So we would get negative 4x squared, get a positive x to the fourth, and a negative 2x to the third. And then the last term multiplied to all three. So we get 8x negative 2x cubed and 4x squared. So we should have 9 terms, so double count, we have 9 terms, because 3 terms times 3 terms would be 9. And now this next one, so we're subtracting what we get from this, so binomial squared, that's going to give us 4. So 4 times 4, 16. 4 times negative x, and then negative x times 4, that's going to be negative 8x. And then negative x times negative x is x squared. Alright, so let's go ahead and combine like terms before we try to integrate all that, because that is a lot. So let's start with the highest powers. So we have 1/4 power term. We have, let's see, the cubes, negative 2, negative 2. So negative 4x cubed. And then the squares, negative 4, and positive 4. That would be negative 4, and then we're subtracting this x squared here. So negative 5x squared. And then the x's, we have an 8 plus another 8, so that'd be 24. And then constants, 16 minus 16 is 0. So we're left with these 4 terms to handle. Way better than what it was before. So now we can go ahead and integrate. And this is a pretty easy integration. We're just raising a power, dividing by the power. So x to the 5th divided by 5. Sorry, that's a 5. And then raise power to x to the 4th and divide by 4. So that's just going to be a negative x to the 4th. And then minus 5 divided by 3, x cubed. And then 12x squared. And we're evaluating that from 0 to 3. So now if you plug the 3 in, you're going to get an answer. Subtract, plug the 0 in. That all cancels out because all the terms have an x in them. So if you plug 3 in, multiply it by pi at the end, you should get 153 pi over 5. So that should be your answer there. Alright, so now the second example. Second example, we have an x squared as a function and x as a function. So we're taking this area and we're going to revolve it around x equals 2. So keep in mind x equals 2 is a vertical line. So my graph doesn't have 2 as an x value, so we're just going to pretend that it's out here somewhere. Okay? So remember, we're not on the y-axis, we're not rotating around the y or rotating around the x. We're rotating around x equals 2. So rotating around a vertical is just like the y-axis, so we're in terms of y. First thing we want to do is switch these to be in terms of y. So that first one's going to be root y, and then this one is going to be just y. Alright, now we're going to set up our boundaries. So remember on the y, so look for intersections at y equals 0, and then here is y equals 1. So we can set that up. So we're going from 0 to 1. Okay, so now always the next step, find big R, little r. We're going to do the same exact thing that we did in the last problem. We're going to start at the axis of rotation, which is x equals 2, and we're going to draw a line towards the function. So if I'm starting over here at x equals 2, drawing a line towards the function, the first one we're going to hit is this green one, which remember is now root y. So that's going to be our little r. And just like we did before, we're going to take our axis of rotation value and subtract the function. So 2 minus root y is going to be our little r. And then we do the same thing with the big R, so we're doing 2 minus y. And then setting up the integral, big R squared minus our little r squared. So there's the setup for the integral. Now, I'm not going to walk through this one. We will have more practice at this. So this is similar to the last one. We're just multiplying the binomials out, combining like terms, and then we can integrate from there. When you get to the integration piece, remember that the square root you can put as a half a power and then deal with it that way. But I would run through this by hand and make sure that you get pi over 2 after you're done integrating and evaluating for the 0 and the 1. Make sure you get pi over 2 as an answer. And that's going to end the video. You have your assignment that you can finish all of the problems on now that you have this practice down. So, I'll see you later.